Metal ore deposits are a finite resource and non-renewable. Once used, they are gone and will not be replaced. The growing need of iron exceeds 800 million tons every year. If it goes on in this rate, iron ores will be exhausted in 100 years. Copper, zinc, lead and tin may not last even for 50 years. Indiscriminate use of metals leads to depletion. Hence, there is a need to conserve metals. Activity series is a table that helps to predict which metal can displace another metal. Using this table, metallurgists can adopt suitable technique in the process of extraction or purification of metals, and this in turn can help us conserve metals and use them more optimally. Zinc will displace copper from copper sulfate solution since zinc is more reactive than copper. Similarly, black silver deposits are obtained when a copper rod is dipped in silver nitrate solution. Copper plate is placed in silver nitrate solution. What do you observe? The colorless solution turns into blue due to the formation of copper nitrate. There is a black deposit noticed at the bottom. Freshly formed silver undergoes oxidation rapidly and gives a black deposit. This principle is used in oxidized silver jewelry. We can write the reaction as given in the visual. When two metals are involved in a chemical reaction, one metal replaces the other metal. But how can we find out which metal will replace the other? Metal that is more reactive displaces the less reactive metal. Can iron displace copper? Yes, iron can displace copper in copper sulfate, because iron is more reactive than copper. The reactivity series of metals helps us to understand this. Click on the View button to refer to the reactivity series. The following activity will also help us to understand this. Take a solution of copper sulfate in a beaker. Drop an iron nail into this solution. Leave the beaker undisturbed for some time. Iron displaced the copper in the solution, resulting in the formation of iron sulfate. This displaced metal is deposited on the iron nail as copper. The copper sulfate solution turned pale green to indicate the presence of iron sulfate. Thus, iron, which is more reactive, displaces copper. However, copper cannot displace iron as it is less reactive than iron. The more reactive metal, which occupies a higher position in the reactivity series, pushes out the less reactive metal and forms its own compound. This is called metal displacement reaction. Magnesium is more reactive than iron. So, magnesium can displace iron. Based on activity series, we can select suitable metallurgical reaction to separate the metal from its ore. In order to extract a metal, the metal oxide must undergo reduction to remove the oxygen to form a free metal. We can classify the reactive series as three categories, namely the most reactive, moderately reactive, and the least reactive. The least reactive metals such as copper, silver, and gold are less prone to oxidation, and hence they are available naturally and have been known to mankind for more than 10,000 years. Oxides of the moderately reactive metals such as zinc, iron, and lead are reducible by carbon in metallurgy to get pure metal. For example, iron oxide is reduced to iron on heating with limestone and carbon monoxide in the blast furnace. Oxides of most reactive metals such as potassium, sodium, calcium, magnesium, and aluminium are difficult to reduce. They are reduced to pure metal by electrolysis in metallurgy. For example, aluminium oxide is reduced to aluminium during electrolysis.